Everyone world over. Green morning, green afternoon, and green evening. All our brothers and sisters across the world, I hope you are taking care of yourself. Please look after yourself, your neighbors, your family, your friends, your community, your society, your civilization. The whole world is one family, Vasudhaiv Kutumbakam. All of us, we are together and we got to take care of each other the best possible way. Ladies and gentlemen, yet another very powerful Sunday evening, the last program of today. We started in the morning at 9:30, and we'll be finishing around 9:30 this evening. We commit to you 12-hour telecast every day, doing the justice with how to empower the education ecosystem. New Education Policy 2020. And today we have got very distinguished guests. Of course, one of them is the session chair. We have got a distinguished speaker, the keynote speaker of the evening, Dr. Raj Vedamji. He is the senior principal engineer at Aveva, that is Katy, Texas, United States. We extend him a very warm welcome. Namaskar, Namaskaram, Vanakkam, and whatever you would like to call in the entire world. Everybody, you should have a greeting your own way. Dr. Vivek Shankar Natarajanji, Professor of Marketing, Lamar University, Texas, United States. Artificial intelligence, machine learning, and deep learning. First of all, we will understand today all these three: artificial intelligence, machine learning, and deep learning. And of course, the New Education Policy 2020, where the Honorable Prime Minister is very keen that every child now in the education ecosystem should be empowered. Our chamber, ICSI, International Chamber for Service Industry, since 1994 is in the service of services sector, bringing all the non-resident Indian diaspora, our corporate and the government interface. And from time to time, we give the policy framework, blueprint, action plan, roadmap, strategies, what all is to be done into services sector empowerment. We all have passed through very difficult times in 2020 world over. 1.65 billion children, they were away from schools, colleges, universities, polytechnics, ITIs. But the doctors and the nurses and the medical people, paramedical people particularly, together in the ecosystem of their health services, they had the system going on. And similar way, our teachers, our educators, our principals, our vice chancellors, our headmasters, and everybody in the education ecosystem also had put in their best of efforts. We salute them, we send our blessings to them, and we are taking only three words of the universe: making education relevant. That is something what our focus is. Now, during lockdown, there were a couple of challenges we have got: economic, social, mental, physical, whatsoever is there. So we were telling that India strongly believes Vasudhaiv Kutumbakam. Heartiest congratulations to India's Prime Minister and India's Education Minister, right in the middle of pandemic, thick of coronavirus, when whole world was passing through difficult patch. And sometimes it's a mind-blowing and mind-boggling also, that how is it possible that in the midst of corona, he gave the priority to the new education policy, which has come after 34 years. 1986 was the last policy, before that 1968, and before that India's independence, that is 1947. Now 29th of July, the new education policy sets a new roadmap for India: arts, commerce, and science, no tight compartments. Art students can take science subject, and science students can take music, and your commerce students can take fashion and textile designing, and vis-a-vis, they can choose the subject of their own choice. Wow. And right from the 6th class onward, children will have coding, they will go to the corporate houses, they will visit industries, and they will have interface. So ladies and gentlemen, the entire holistic approach when we are talking about, I think quite a few of us, not only skilling, we would require reskilling as well. That is the mantra for the educators particularly. And there's a beautiful definition which has emerged, I'll share in a little while with all of us. Education is now learning centric. This slide is very, very important. Something we got to understand that after the Britishers left this country, India got into teaching centric. That means the teacher right in front on the blackboard, and whatever they are dictating, you just jot down, appear for the exam, vomit it out there, get your percentage, get your marks, and you move ahead. And that is one fine day when you appear for the exam decides who you are, what is your caliber, and where do you stand with those subjects. Now, from teaching centric, the education policy moved to learning centric. That is, I'm talking about the new education policy. And this pandemic, when it brought blended learning, flip learning, digital learning, outside classroom learning, innovative learning, creative learning, and altogether out of four walls learning, whatever mode mean you can think of, whatever you can apply, but the education should be perceived, received, conceived, whatever you want to talk. So from learning centric, it moved to, from teaching centric, it moved to learning centric. Okay. But this corona has moved one step forward. One of the stats which has come is, this is a very important statement which I wish to share with everybody. The new education policy, whatever time it would have taken for next 10 years, whatever we would have implemented in next 10 years, because of the coronavirus and because of all these blended strategies and innovative technology based strategies, the education has moved like a tsunami, and that is 10 years ahead of times. That means we have the leapfrog and we had gone 10 years ahead, what otherwise it would have happened. So the definition of learning centric also has changed. From teaching centric, we came to learning centric. From learning centric, we have come to teacher's role as a facilitator and complete accountability, what the child has perceived and what the child has picked up. Now there's a one more step which has gone, because how teachers will facilitate, what will they facilitate, what would they give to children? Children are already ahead of them. One of the studies shows that today's children, those are born, they are 137% taco savvy more as compared to existing universe. That means by nature, it has come. So once it has come, the role of teacher again will change. So teaching centric, learning centric, teacher as a facilitator, and the last and the new definition is co-learners, co-learners, co-learners. That means both are learning. You're also picking up something from that particular interaction, and children are also picking up. So the education has completely changed now. Technology, when you talk about AR, VR, AI, all in education. So when you talk about it, what is going to be the future of education? Okay. In the new education policy, vocationals have got very important subject. How? And that is something very important. When in 1835, February, that is the 4th of February or 2nd of February, Macaulay made statement in the British Parliament that I wish to inform the House of Lords that when I was in India, first of all, I didn't see any beggar. I didn't see anybody unemployed. And at the same time, their education system, unless we do not destroy their education system, we cannot stay longer and for a long duration in India. If we are keen to rule over there, let's first destroy their education ecosystem. It was a community-based learning. And when I talk about all that Guru Shiksha Parampara, and when I talk about Gurukuls, vocationals were having a great respect that point of time, and it was very important. We lost it, and now it's coming back. If somebody wants to become a plumber or an electrician or air conditioning repairing or a carpenter or a mason or a vehicle mechanic, these all jobs today in entire Delhi, you won't find a plumber. You have got so much of difficulty. You will have everything. You will have all babus but you will not be able to get anybody who can fix that problem. So we have gone very far. What is the purpose of education? We got to understand that in reality. So thereby, ladies and gentlemen, a lot of workshops and training part has to be done. Now, is knowledge important or is skills important? If I take out the card of the knowledge, I just have a tremble only on the top. But if I don't impart skills, the knowledge is of no use to me. Because there's a plenty of knowledge, it is coming from all directions. Information is coming from all directions. Children do not need, it is over bombarded. In lifetime, you can't study in one subject. And after Corona, it has been told there are two things very important. One is soft skills and another is life skills. And when you're talking about soft skills, our chamber has made the complete synthesized information. There are 140 soft skills which are required. We will list out sometime and we'll share with all of you. We're going to have a separate program for that. Post-Corona, there are 5 core competencies which have come: adaptability, creativity, critical thinking, resilience, and self-management. And from skills, we have moved to competencies. From competencies, we'll move to capabilities. And I've been told that something else is coming after capabilities also. We got to read it. Honorable Prime Minister of India, through his innovative and dynamic efforts, wants to make India Atmanirbhar Bharat. But hats off to this gentleman to take care of such a diversified country with so many tribes, so many languages, so many culture, art, craft. India itself is a very big continent in itself. So many people with so many varieties, and on the top of everything, democracy. It is, I think it is the most difficult task for somebody, because whatever Britishers left, people just wanted to move on with that only. But now India is thinking, India is growing, India is becoming self-reliant. And we all have to contribute towards building India, Bharat, towards self-reliant, Atmanirbhar Bharat. And that is going to be possible when children should not ask for jobs now. We should not look for easy paths. We should not look for easy things. If I get a government job, then I have not to work because now I will retire from here only. He's trying to bring the sea changes in the whole system, its own way. There has to be an accountability of every person, every soul. If I'm a teacher, what am I teaching? And what is the outcome of that teaching? That is also something very important, which we have to work it out and we have to plan it out. Self-employment is very important, which we have to take care of, because you got to be your own boss. You got to be taking care of your own things. And then comes entrepreneurship. You got to become an entrepreneur. Every child, whosoever is watching this particular program, you have been sent by God on this planet. You have an idea. You have capabilities. You have got knowledge. You have got information. You got to become your own leader. Work in a team. Be assertive. And you can do wonders on this particular planet. And it is very, very much possible. This morning, I was watching one program, and that was coming, and there were 5 questions, and very interesting questions, which I would like to share. Who am I? Where am I from? Why I am here? What can I do? And where am I going? These 5 questions to be answered. That was something very interesting. And I was just doing my introspect. Okay. Startups. Great. No worries. Everybody will not be successful, but at least start something. Government is creating an environment for you. A lot of money is floating around. Government is holding your hand. They are telling, even if your business doesn't survive, but if you have good intention and good idea, come forward, move forward. A lot of ideas are being invited. A lot of innovation, incubation, Atal Tinkering Lab, Atal Incubation. Niti Aayog is doing great job. All of them, they are putting in efforts. Ministry of Micro, Small and Medium Enterprise, Ministry of Skill Development and Entrepreneurship, Ministry of Education. And the entire ecosystem is with the youth. And India being the youngest nation world over, we have got some responsibility because people are aging world over. Ministry of Micro, Small and Medium Enterprise, the big chunk, because this ministry, if we go to the website, you will find it's a mind-blowing, and I wish I'm 15 to 16 to 17 years again of age, what all government is rolling out and what all they want to invite ideas. They want to get bright ideas. All the schemes are for our youth. So our brothers and sisters and our children, please work on that. Ministry of Skill Development and Entrepreneurship, they are doing great job. New ministry. There are 37 sector skill councils in India at present, and we are working with most of them. This is the Wellness Sector Skill Council, where our chamber on Swatantrata Divas on 15th August 2020, with 15 Yodha of the Wellness for the holistic healing, we had done the program. Here is Colonel from the Indian Army, Anil Kumar Pokhriyal, Management, Entrepreneurship and Professional Skill Council. They are doing great job. All the startups, those are associated with their council, we brought on this platform and they all shared their experiences. Then in life, you need something to do. Here is a very dynamic who is from the industry, Mr. Mohit Soni, Media Entertainment Sector Skill Council in India, radio, television, theater, music, films, animation, digital, whatever we can talk about. We did the series with them a long way. Swami Vivekanand's teaching. And yesterday we had a program, Awake to Vivek. Every Saturday evening, 5 p.m., we have a special program, Swami Vivekanandji's teachings for education and youth empowerment. And I'm so grateful to Swami Sarvapriyanandaji from New York. He came all the way for the program. And same way, our Swamiji in Chicago, Ishtamananji, he also had come. It's such a great gesture of theirs. Then, when you're thinking creative, innovative, working hard, tirelessly, then you need your good health also. So our Ayurveda plays a very important role. Every Saturday evening at 6:30, we have got Ayurveda for the global wellness deliberation. Nowadays, Professor Dr. Parmeshwar Arora ji is coming, and he's a gold medalist in Ayurveda. What a beautiful pathy he gives, how to heal your body, yourself. Everything is within your body. So all my youngsters, if you are a healthy mind, healthy body, you will do very well in life. And that goes with our teaching faculty also. Please take care of yourself and take care of your students in schools, colleges, universities, because these children are today and these children are tomorrow. Everybody says these children are future. Why? They are present also. Why do we talk only future? They are present also. Don't underestimate the potential of these youngsters. So yesterday evening, we have hosted 640th webinar, and it was so nice. Yesterday, he talked about the common skill ailments. He's talking about all kind of difficulties. We have done, ladies and gentlemen, 39 webinars on Saturdays, exclusively dedicated to Ayurveda. And we are struggling very hard that in the insurance policy now, with allopathic, Ayurveda should also be included. Some of the countries have done. Every Sunday morning. Today is Sunday. This morning we started at 9:30 in the morning with Professor Satyendra Dhiman from the Woodbury University, Vidya Se Adhyatam Vidya Ki Aur, an integrative series of Shrimad Bhagavad Gita and 10 principal Upanishad that we are having every Sunday. Sunday 12:30, every Sunday, ways to resource management. And today there was a beautiful inputs. Those of us who missed it in the morning, you can see it on the YouTube. If you go to GS Motivator, in your own time, you can see today within half an hour, they have given that whatever comes out of your kitchen, how can you turn that into resource? Nothing is waste. It is all our mindset. We have started wasting and we say throw, 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 but you don't know whatever you're throwing, that is a food for animals, that's a fodder for our couple of other things, and at the same time, that's a mineral for our plantation and our prakriti. 3 p.m., We were in Northeast India and ASEAN, 10 beautiful countries in the ASEAN and 8 beautiful states in India. That is the northeast part of India. And we had deliberations, the budget session 2021 and what is for education with them. And just before this program, we had 645th webinar, Inclusive Development for Aspirational India, Role of Micro, Small and Medium Enterprise. And ladies and gentlemen, I wish to share that from the budget we have picked up education, and from education we have picked up the agenda of 100 scenic schools coming up in India. The government has initiated. Our chamber has already done 3 programs last week. On the first budget had come, second, third and fourth. I invited 3 colonels. They were with us, and Monday, Tuesday, Wednesday, Thursday, 4 days are dedicated for scenic schools, because Friday we have got on water management from Singapore, Saturday we have got Swami Vivekanand ji, and Sunday we have got MSME at 5 p.m. Colonel Palaram is coming on Monday, and all the people, those are associated with the scenic schools, they are coming. We want to do the nation building. The younger generation which is coming now in India, how they should become today and tomorrow's leader. So it's a cradle of leadership what we are developing. 12 hours are beaming without charging any money, all complimentary. Here is the complete canvas of our program, 9:30 a.m. to 9:30 p.m. You can take it. 12 hours. Can you believe it? Every day we are doing it, every day, non-stop, all the 7 days in a week. And that is the way we are going. Education got to be relevant to our day-to-day life. Education should not be theoretical. It should not be in the classroom. Every teacher, every person, whosoever is associated in education should be accountable. Water shortage is going to be a big problem. When I talk about Bangalore, when I talk about Chennai, when I talk about the entire state of Punjab, when I talk about a couple of other places in India, world over the data, what we are collecting from the different continents and countries, ladies and gentlemen, the world saw First World War, Second World War, the third, I do not want to say, but it's going to be related to water crisis, water shortage, water sharing, and some countries, those are making dams. They will have a choice when they want to make a drought in your country and when they want to flood your country. So water related issues is very serious, and women empowerment is very, very important with that, because water saving and every drop of water saving starts from my home. And whatever capacity, women empowerment is very important. Your health and wellness is very important. This is my rooftop. Right from 25th of March, I'm growing my own organic vegetables. And that's why this old man at this age, 70 plus, you see my energy is that of 20-year-old boy. This is all because of my living lifestyle and positive thought process. Think positive, talk positive, walk positive, dream positive, live positive. Everything should be positive. And then you see the nature, because we are not separate from the trees and insects and plants and animals. They are the part of our ecosystem. The more we go away from there, we will have difficulties. They are the part of our life and our ecosystem. Organic farming, we would request every child start working on some startups we require on organic farming innovations also. Startups, entrepreneurships, and MSME, we all got to work up. Youth empowerment, teachers empowerment, and our chamber is proud. We set up India's first finishing school lab in 1994, where soft skills and life skills being taken care of, teacher empowerment and youth empowerment. And we are very happy. And this is the milestone for ICSI for 2021. Teachers and youth empowerment, making education relevant, skills, competencies, and capabilities, micro, small, and medium enterprise, research and innovation, technology, health and wellness, water management, and women empowerment. These are the core peripheral, but everything is focused on service industry, contributing to Atmanirbhar Bharat. Incubation centers are very important, and our chamber facilitates colleges, schools, universities, polytechnics, ITIs, finishing labs for soft skills and life skills. Our chamber helps. And then Niti Aayog's program, Atal Tinkering Lab in schools. Ladies and gentlemen, our chamber collected the data from the world over. World will be in now new order. This golden triangle is going to be altogether different. It's not Delhi, Agra, Jaipur. It's your basic food, your basic health, and your basic education. Sustainable development of the world. B2B is now back to basics. That is our future, not business to business, back to basics. Our recommendations to the Indian corporate and our Indian diaspora world over. Next 5 years, let's focus and let's spend the CSR, whatever is being done by Indian corporate in India, it should be invested in education ecosystem. Why do we look towards somewhere else? Let's not waste the money and let's not construct physical infrastructure. We require digital infrastructures. We got to move with the times. And non-resident Indians, don't give the money to anybody. Don't invest money anywhere. Just focus in your own village, in your own native place, where your ancestral, your grandparents and your parents, whosoever is there, adopt few children, adopt a school, give them some devices, give them some technology, do some hand holding directly. That is the way we should come out. And whatever human mind can conceive and believe, it can achieve. Let's come together, making education relevant. So, ladies and gentlemen, join me in extending a very warm welcome this morning, this afternoon, this evening to our very distinguished guest, Dr. Raj Vedam and Dr. Vivek Shankar Natarajanji. And there they are. Namaskar, Vanakkam, Namaskaran, and whatever you want to call it. And with these words, I extend a very hearty welcome to both of you. And I would request our advisor to the chamber, Professor Vivek Shankar Natarajan, to take on the floor from here and to proceed. With these words, hearty welcome to both of you.
Thank you. Namaskar. Subha Sayankalam to those of you in Bharat. And warm good morning to those of us here in the US. Today is, let me start with the prayer. Varnanam arthasangrahanam rasanam chandasamapi mangalanam chakartaro vande vani vinayako. This is from Tulsidas ji's Shiksha Patra. Then Vagartha viva samprakto Vagartha pratipatte jagatah pitaro vande Parvati Parameshwaro. This is from Sri Kalidasa's Kumara Sambhavam. So with that, I would like to, it's a pleasure to welcome and introduce my very good friend. We know each other for the last, a decade or so, Sri Raj Vedam ji. We share many things in common. Both of us hail from the city of boiled beans, as they call it, Bengaluru. So we are Bangalore boys, but we are native, our mother tongue is Tamil. So, that's one thing common to us. Both of us have undergraduates in electrical engineering, but that's how that's the only, these are two things in common. And we are passionate about Bharat and its civilization identity. Of course, after that, it diverges. Raj Vedam ji has pursued, he has a bachelor's degree in electrical engineering, and then he pursued and got a master's degree in electrical engineering from the very prestigious Indian Institute of Science, started by, of course, many people, but it was inspired by Swami Vivekananda and I think JRD, the Tatas funded it. So it's also called Tata Institute. So it's a very prestigious institution, very, very hard to get in and hard to get out too. So it's both, entry and exit barriers are very high. So somebody makes it, their grace also are really very good, especially in a discipline like electrical engineering. And then he came to the US, pursued a PhD and in electrical engineering again, and he has been working in various industries. He has, Rajji has worked in chip design, he has worked in automobile, I believe, he has worked in energy, and he's also been a passionate passionate in coding, so there was about 5 or 10 years back, the Netflix had a competition on developing the algorithm to best predict what videos or what movies people want to watch. It was a very intense competition, $1 million prize money. Most people were playing with competitive teams, and they were having multiple high powerful computers and servers working on this problem. Our Rajji was more like a one-man army, Atmanirbhar guy. He just did it with his own machine, and he came very close. So that tells you he's a man who's up for a challenge, and a man of many. He's a typical Renaissance man. He's an amateur guitarist, and he always builds out a few tunes. I've heard him singing a lot of music from the Tamil music director Ilayaraja. And he sings that very passionately. And now he has turned his analytical attention, lens to the problems of Indian history. So he has been doing a meticulous job. He's he used to be part of the Indian Historical Awareness and Research, of which one of our earlier guests, Jay Kumar ji, is the founder, and we have also had Sahana Singh on this show. So Raj is part, and of course Professor Sarath Menon. So all of these are the bright minds, bright sparks, as we call it, behind the IHAR initiative. And Raji is no stranger to India. He visits India for, he used to come at least twice a year. And now after the pandemic, he might have put it on a brief hold. And he kind of visits passionately, goes around like a traveling salesman. He goes around city to city giving talks. So one of these days I was telling him he could run for office with the kind of thing he makes. And he's also an astronomer, on Facebook. I'm out of Facebook now for a while, but on Facebook, he will always say, you can see the Uranus and you can see this, that. The only thing I can see is the moon. I can't see anything beyond the moon, and that too on a full moon day. But today is also a very interesting day for those of us who live in the US. The evening is Super Bowl. So Super Bowl is when we have two best teams fight it out for a challenge in the American football. So, but for most Indians, Super Bowl means it's a Super Bowl of pakoras and chips and all that, and they sit in front of the TV and eat. So it's a great day for many of us. So with that, the weather is looking good. This is the first Sunday of February. That's when Super Bowl happens. So with that, I'm going to request Rajji to take over and talk about, primarily he's going to talk about artificial intelligence and data and all that. But somewhere I'm also going to ask him to talk about his work in history. And maybe that's another panel. We need another whole session on that. But if you can give a little trailer there, and also possible also talk a little bit about his passion in music and how that feeds off into his work as an engineer. So with that, Raj Vedamji, please get started. The floor is yours. Thank you.
Thank you, Professor Vivek-ji and Dr. Gulshan-ji. It's a real pleasure and an honor to come on this platform and talk. Let me share my screen. I don't know if you can see my screen yet. Tell me when you can.
Yes, sir.
We can see.
Okay. So thank you once again. And today I will talk on AI, which I always put in inverted quotes because I've been very unhappy with this name, artificial intelligence, very emotive word, which communicates much more than what it really is. I prefer to call it computational inference because that is what it is. And I'll be talking about this. Today, what we see is there is a lot of what we can say as hype or paranoia about what we call as artificial intelligence. And people ask, where is the reality? Where is this? And I hope today's talk will set the stage for a bigger discussion on this one. On one side, we see people who say this entity called AI will solve all problems of humanity, intelligent agents, autonomous agents that will handle all of our issues. Machines will do all of our work, and we're going to have a future utopia. This is what some people would like us to believe. On the other extreme, there are people who say, no, AI is a dangerous technology. It'll take over humanity. There's a doomsday scenario. There's something called a singularity that is pretty nearby. And there are rogue corporations today that will usurp authority and control the entire world. There's a dystopian future out there. And there's a middle ground to go over here, which I and many others also belong to over here, where we see this term artificial intelligence really is inferences which we make with computational methods. Computational methods typically on a computer, and then it implies that there's somebody who's coding this, somebody who's got an algorithm in place to do something, and some primary effects and secondary effects are coming out of such inferences. So it will neither solve all our issues, because our issues are far beyond those that can be solved by AI alone, nor will it become a doomsday technology. It has its place as a computational machine to automate many tasks and make our lives easier and more efficient and productive. There's no doubt about it at all. And there is, of course, a strong need to have oversight on the technologies and issues of ownership of this entity called artificial intelligence technology. And we'll visit some of these things in this talk. So I love to talk about history, because history is something that gives us a big picture of where we are. Otherwise, we are lost in the woods. You're looking at the leaves and wondering, oh my God, what is going on over here? But if you go far out enough, you can see that, yes, there's a forest over here. This is what the forest looks like. So I'd like to go a little bit into the history of what we call AI, or computational inferences. So very early on, there were people who said, if I can do something that requires observation, measurement, and taking some real world actions to affect something, that is intelligence. For example, if you tell a 7-year-old child, you open a tap where water is flowing into a bucket, tell that child, watch that bucket. When the bucket reaches, the water reaches the top level, turn off the tap. Now the child will watch that, and when it goes to the water reaches the top level, the child will turn off the tap. And we will say this is a measure of intelligence, because you can't ask your dog to do it. You can't ask your cat to do it, obviously. So it requires some modicum of what we call intelligence. But then we know for a very long time, not from industrial era, but from pre-industrial era, that humans have contrived all kinds of artifacts to do precisely this kind of mimicking of human action, where you take a measurement in the real world, you make an observation of what is going on, you have a reference for where that entity needs to be, and you take a control action so that that will go to where it needs to go. That is shown schematically over here, what we call control systems. By the way, this is my PhD and other such things, where you have a reference input, you have a measurement through a transducer, and you take the error, pass it through a controller, and you control some entity, knowing fully well that subject to real world disturbances, noise, and all those kinds of things. So today we know that control systems can do what we think is intelligence. And we see a variety of things like continuous, discrete, sample data, linear, nonlinear, distributed, time invariant, time varying, deterministic, stochastic, computer controlled, self-tuning, adaptive, all these entities over here which do this real world entity. And this is given a name called cybernetics. Cybernetics is a term by the Soviet mathematicians a long time ago. And we've seen even in the industrial era, when people wanted to control, when James Watt had invented the steam engine, they wanted to control the steam pressure. There was a governor that would be based on centrifugal force, spinning centrifugal force. You could tune that will regulate the pressure. Right from that era onward to military era, when people wanted to aim where they're going to fire a gun so that a missile or a bullet would go and hit a target, starting from those kind of things and so on, people have known control systems can do a whole lot of things. And today we got computers to do this. So is this intelligence? Well, this was a subject that was tackled by a group that met at Dartmouth University in 1956, when they wanted to show that cybernetics isn't really what we're talking when we say artificial intelligence. Artificial intelligence is something else. And they try to define what artificial intelligence is, what intelligent agents are, and so on. And this is what people say as a birth of AI, if you will. This coincided with also the development of the initial mainframe computers like UNIVAC and these kind of very, very early computers also coming in the scene, suddenly allowing people to move from analog computer era to digital computers. And the ability to see that, hey, you can program these things and make these computers do something for us. So that was a time when this development of the technology, something called perceptron was proposed. And also we see there's the breakthrough of applications. For example, there was a robot over here called Unimate that was used for production in General Motors in 1961, very, very early. There's also a robot that can play music in Japan, 1973, around that time. And there was also, once perceptron was proposed, there were a lot of people trying to see, all right, perceptrons is like a learning object, a mathematical learning object. What can we use this to learn? There's a lot of interest that we can see in the 50s, 60s, 70s, and so on. So around 74, there was a disillusionment because there was a realization that the perceptron could not learn certain logical functions. Once they found a very critical logical function called XOR could not be learned by a perceptron, people knew that's how limited utility. So it's just an interesting entity. And so interest fell off between 74 to and so on. And after that, there was a growth in something called expert systems. Expert systems was intended to mimic the knowledge of experts in the real world. And once that came about, neural nets once again came with the addition of something that we call a hidden layer. So multiple layer perceptron and the backpropagation algorithm, that led to a growth, a big growth that we see till around 87 and so on. And I was part of this wave when this learning was going on in this time frame, expert systems and backpropagation algorithms and neural nets. And this coincided with the growth of computer technology also. The PC was made available to many people, and this aided that kind of a growth. The second winter came about because once again, it was seen that there was limitations with this technology. There's a limitation in the computer hardware. There's a limitation how much you could scale this up for real world applications. So when that was seen, people saw this more as a toy technology, something that can do some toy problems and so on, but how can you scale it up? That was a big issue. And once again, interest fell. Around 95, when the Pentium computer came on the scene, when more powerful computers, more RAM and other things are available, additionally, in theoretical learning algorithms, things like adaptive boosting algorithms, support vector machines, and these things came about, and IBM got its Deep Blue technology demonstrator computer that could beat the human champion at chess. Once again, interest has been growing in AI. That has led today to the third burst, the development of with big data, deep learning, and all these kind of things. When people are seeing, yes, we can indeed use this technology, harness it in some way to automate some everyday jobs that we might have and allow the computer to do perhaps a better job than what we can do and quicker. So this neural network with so-called deep learning capability came about and applied to things like voice, vision, and all these kind of things. And we see that today we are here with Apple Siri, driverless car, and playing games like AlphaGo, Watson, and many, many, many applications in 2021. This is where we are today. So in a quick history, we see that very early when Alan Turing proposed the Turing Test. The Turing Test is something where he proposed that if somebody could have a conversation with a hidden interlocutor behind a screen, maybe you don't know who that locutor is, and if you think you're having an intelligent conversation with that entity, then that is a pass for machine intelligence. That is what he proposed. And that Turing test became a famous test of a threshold to measure intelligence with. I think it is relevant even today, even with the best AI that you have today. This test is still relevant where you can try to see, are you interacting with an intelligent entity or not? However, there are some caveats. I'll talk about this later. So like we said, 1955, AI was born, Unimate, ELIZA, Shaky was one of the robots that is controlled by a mini computer. In those days, the AI Winter, Deep Blue, Kismet. We talked about Aibo, Sony's computer, Pet Dog. All of us know about Roomba, the vacuum cleaner that can learn the layout of your floor, Siri, Watson, Eugene, Alexa, Tay, which is Microsoft chatbot, which came about, and AlphaGo. And so this is where we are today. So I'd like to now take a step back and ask, what are these tech areas which we can address with this entity that we are calling artificial intelligence, or what we call computational inference? I divided this into three areas, cognitive areas. we have seen that things like expert systems, fuzzy logic, these genetic algorithms, these were all used in an effort to capture a real world problem using mathematics, using models, using some way of learning the real world and using that for decision making, some kind of a decision that you might have to make. This is where these ideas came from. So expert systems, fuzzy logic, genetic algorithms, what we call adaptive systems, things that could change the requirements. For example, when the space shuttle comes from outer space into Earth's atmosphere, the parameters governing that model change by a factor of 1 in 5,000. That is the amount of parametric change that you have. So a controller that is built to control something in outer space may not work once you come into inner space. You have a problem over there. So you need to adapt to the requirement. Similarly, for example, our LCA and other flexible aircraft, when they're on the ground, when they're flying at below the speed of sound, the parameters can be controlled by a certain kind of control system. But when they break the sound barrier and they go really, really fast, the geometry of these flexible aircraft also changes. When the geometry changes, then even the controller, the parameters, everything have changed. You need to adapt. And that is where adaptive systems came from. Very, very productive field that was enabled us to do a lot more than what we can do with fixed controllers. That gave way to learning systems. That gave way to something that we called artificial neural nets and so on. And today we see applications like autonomous locomotion. Control systems are at the heart. Control systems and optimization algorithms. These are the heart of all of these applications. We see applications in robotics, driverless vehicles, path planning, navigation, and remote sensing, computer vision, and so on. And today, one more very big thing is man-machine interface. How do I work with a computer? Is the only way through perhaps a computer keyboard, or perhaps I can do speech recognition, or perhaps visual, and perhaps you can talk to a computer with natural language, and maybe even go into what we call virtual reality worlds constructed in a computer simulated environment. And what kind of multiple sensors are out there in the real world with which I can interface to a machine. So all these tech areas meld together, and this is what we call computational inferences to navigate between algorithms, computers, applications, and the real world. And this is termed as artificial intelligence. So again, what is it in a computational framework? Like I said, in terms of logic, this entity is rule-based systems, expert systems, can be used for alarms, diagnostics, and so on. Application of statistics, probability, likelihood functions, regression methods, information theory can be used for decision support. In terms of what we call machine learning, Bayesian inference, decision trees, support vector machines, natural language processing, ensemble methods, and what we call neural nets and deep learning, we can use it for speech recognition, recommendation systems. And obviously, we talked about systems, control theory, signal and image processing used all over for manufacturing, aircraft, cameras, audio, you name it, millions more, not just these things. So all of these entities today have been called with this umbrella term, artificial intelligence, which really is computational inferences applied to the world of technology. Every aspect of our technological world can be controlled by algorithms that are based on mathematics, that can be based upon some kind of optimization methods, if you will, that will fit the model to the real world, and you can use that for decision-making in the real world. That is all one can say when you try to encapsulate what this AI is. So in terms of usage, we can see the usage has literally exploded. Literally, you can talk about application of this entity called AI in banking, personal finance, transport, retail, education, communication, media, entertainment, healthcare, real estate, social networks, defense, smart homes, cybersecurity, insurance, politics, and government. You name it. Every aspect of our everyday life is pervasively touched by these autonomous agents that have come out of this technology that we call AI. That is the bottom line. And this is why it is critically important that we need to understand what it is. We need to have a big picture idea of what it is. We need to have detailed information of what the algorithms used over here. We need to make sure that we understand this technology rather than have an emotive approach to this that's a doomsday engine or utopian engine and so on. one needs to have a grasp of this at a very deep level. So there are several methods of computational inference. This entity that we call machine learning, which in turn is nothing more than an optimization problem based upon a model, some real world, some data. How do we fit the real world input-output behavior to the model that we have selected? And how are we going to tune the unknown parameters? That is what machine learning is. And there are two kinds of machine learning, supervised or unsupervised. In supervised learning, things like regression is typically used for a long time. It's not something new. For a very long time, regression has been used. Things like weather forecasting, market forecasting, and things like that. And for classification problems, this is very, very important today. Things like image classification. Is an X-ray that I have, is it cancerous or not cancerous, showing cancer or no cancer, these kind of things. Or even is a picture that I have, is this person or not this person, things like that. Customer retention, diagnostics, identity fraud, and so on. Unsupervised, things like clustering. I've talked a little bit about recommender systems over here, marketing, computer segment, dimensionality reduction. When you have big data, what kind of visualization, feature extraction, and so on. Then reinforcement learning, things like real-time decision-making, navigation, learning tasks, skill acquisition, playing games, all of these things come over here. So this is a nice way to look at all of these things, which in turn, remember, the embedding over here is one of optimization. How is optimization used in the real world to try to reduce problems down to a model that we have and use that model judiciously so that we can solve some real world problems with limited applicability. That is the bottom line over here. And we see that AI today has come in many, many areas: predictive learning, analytics, deep learning, what we call machine learning, then in text to speech or speech to text for speech processing, for image recognition, what we call machine vision, for natural language processing, things like classification, translation, data extraction. Expert systems talked about this. How do we mimic the behavior of an expert within a computer and analyze what is going on in the real world? For planning and optimization, for robotics and for cars, driverless cars, and all of these kind of things. This is where the world is going to with computational technologies. And I'd like to give an insight that hardware is what has fueled computation over time. So we have seen that computational abilities scale up over time. So this is a very busy slide, and it shows the growth in computer chip, the CPU, central processing unit that we're talking about, from a very early era all the way to present times in 2020 and so on. It shows how computers have evolved. And what we are seeing is on this y-axis, we have the transistor count that has been put into the VLSI. VLSI is very large scale integration. It's a chip, that's a central chip on your computer motherboard or your cell phone or any kind of device that does computing has got one such entity. And in around 1970 or so, 70s, Intel came out with its 4004 and 8008 machines. And that led to the hugely popular Intel 8085 by the mid 70s and so on, and 8088 and 8186. I learned my assembly code on these machines. I remember that way back, I'd learned on how to code assembly code on these machines, learn microprocessors and those kinds of things. And these eventually grew, as we can see over here, from 1,000 transistors to 5,000 transistors. When you're talking about 80186, we are talking about 50,000 transistors that have been put in that chip. And by the time we come over here to Pentium, around 1995 or so, we are talking about almost 500,000, 5 million over here. It's 5 million transistors over here. And from 5 million to 10 million transistors, AMD K6, to 50 million transistors, to 100 million, to 500 million. And we are talking about 1 billion transistors by the time we have come to approximately this time frame over here, 2008, 2009, we're talking about 1 billion transistors. That has gone to 5 billion transistors, 10 billion transistors. And today we are flirting with 50 billion transistors on some of the most advanced chips that we have out there. And what Gordon Moore talked about, he's Intel's founder. What he said is the number of transistors and microchips doubles every year. It was an informal statement that he made that has come to be called informally as Moore's law, that every 2 years, the number of transistors doubles on the chip. And there's some technical and some market reasons why these things happen. So this is what we are seeing, the doubling of transistors. We are seeing that from 1970s to 2020, this is the kind of transistor growth that we are seeing, this line over here in actual units. We also see performance. Performance also goes up. And as performance goes up, our ability to do tasks also has increased with time. Between 1990 to present time, we are seeing the linearly growing up and somewhat leveling off over here in single-threaded performance. We've also seen this, by the way, this is the reason why we go to multi-core. Multi-core allows us to somewhat flatten, not flatten, but make this curve almost go towards linear. It's not linear, but towards linear. We've also seen that the operating frequency of the clock, even that has got limited. We cannot push the clock frequency too much because of some theoretical requirements and practical requirements also, limitations rather. And also we see the wattage, how much of power is consumed by these chips. From a low power, we're seeing that now we're talking about in the order of 100 watts is what is used by your chip, requiring some pretty good cooling on your chips, and the number of logical cores. This is what we are seeing, that the number of transistors is doubling. And as microprocessor technology has improved, so has our computational ability. We are able to address larger and larger problems with the convenience of working on your laptop computer or your cell phone or your note or your desktop computer and do things that was not possible in the 80s, things that you cannot do in the 90s. You can do that today, 2000s, you can do that today. So this is what has given the freedom to tackle these bigger and bigger problems. So what we've seen is the feature size of transistors from 130 nanometers. It is miniaturization has happened to a point where today we are at 7 nanometers and less. We are talking about atomic dimensions right now. We're talking about transistors, just a few atomic dimensions wide. That is the kind of dimension over here. We also see what is the dollars per mm square in terms of real estate. We see the cost also goes up. The cost goes up as we do miniaturization because something called yield, semiconductor yield, that is impacted the more and more you miniaturize. But taking both of these things together, that you can miniaturize, you can double the number of transistors, every technology and so on, we are seeing that the dollars per transistor is actually going down. So as we go to 7 nanometers, we see that our cost per transistor actually goes down. So this is what is driving it. And as we go towards 5 nanometers and others, we will face severe technological challenges, but something might come out of that. So having looked at what is AI or computational inference, we looked at some of the algorithms, we looked at some of the applications, we looked how hardware is fueling the ability to do computation. I'd now like to take an example, something called a recommendation system. And it showed that psychometric profiles can be built with big data for anybody. You needn't even be a participant in the economy, the digital economy today. Even without being a participant, one can build a psychometric profile on your likes, dislikes, and these kind of things. And the technology for that today is something called recommendation system. So what are recommender systems? Peer recommendation, things like information. It's an information filtering mechanism. It can predict a user's rating or preference for an item. It is used today extensively by online retailers. For example, Amazon recommends items that you buy based on ensemble viewing, selections, past purchases, and so on. Netflix, for example, offers predictions of movies you might like based on ensemble past ratings. And things like Pandora, it's a radio that offers music selection based on ensemble and your past ratings. YouTube can suggest videos based on your past viewed content. Facebook, LinkedIn, and others offer new friend suggestions, groups to join, and so on based upon. Just an example of several ways recommendation systems are being harnessed. And this is the backbone of today's e-commerce. When you're talking about recommender systems, we are talking about things like content filtering, collaborative filtering, knowledge-based filtering, hybrid filtering. In collaborative filtering, which I focused on, it can be memory-based, model-based, hybrid, several technologies are out there today. And I'd like to talk to you about Netflix challenge. This is something that my good friend, Professor Vivek, had talked about. So way back in the mid to late 2000s, Netflix came out there and issued a challenge to the public to outsource their R&D, literally. So they're in the business of renting DVDs in those days and streaming content. And they use a recommendation tool called Cinematch. Based on user and ensemble inputs, it makes movie recommendations to people. So they provided the public with a test set of anonymized actual but modified data on 17,000 movies, about 500,000 users, and about 100 million ratings between 1 to 5. And the question was, can you use this data and learn what an unknown user, whether he'd like a movie at a rating of 1, 2, 3, 4, or 5 or not like it. And they said that our algorithm is giving us a metric of 0.9525. If anybody can make a 10% improvement, and they can win their $1 million prize. And needless to say, a whole lot of people jumped in at that point because they're driven by the intellectual content over here to try to see if their algorithm can accomplish this. And eventually it was won by AT&T's team, Belcor. So what was it all about? If you had movies 1 to 17,000, customers 1 to 500,000, and this movie might have been seen by customer 2 who rated it at 3 and some other customer at 1, customer N at 5, and so a lot of holes over here. We don't know how customer 1 will respond to movie 1, for example. We don't know that. So given an incomplete matrix, can we obtain the missing values? So the kind of approach that several people, including myself, took was to see that each movie we can think about as having some features. The features could be things like, is it a comedy? Is it a drama, violence, family, thriller, cartoon? You can have as many features as you like. And what kind of taste should a customer have? Does a customer like comedy, like drama, like violence, or he thoroughly hates violence, so he'll have a 0 rating for violence and so on. So once you do this, then one can have a mathematical model for this. It can be used in a pseudo, what we call SVD model. And the machine learning model was something like this. If you had N features, what is a predicted rating of movie I by customer J? That would be this kind of a summation, which we can abstract into an optimization model, into a model which can be solved using put into this criterion function. This criterion function is saying, I don't know what the movie features are. I don't know what the customer likings are. But if I knew these parameters, I could choose them in such a way that the actual rating minus the predicted rating, that can be minimized. That is the objective over here. And we use something called mathematical optimization to search in the parameter space to minimize this. That is the bottom line of machine learning and about recommender systems. Now, having said that, I'd like to go to the last 2 points over here. The future. What is the future? What are the issues? So the future holds increased automation based on computational inference. There's a lot of promise for this. If you compare our brains today to the computer, human brains, it's not a good comparison, but there are people who are attempting to do this. So I put a couple of slides over here based on what people have said. For example, if you just have to deal with input and output, information processing and remembering incidents and things of that nature, then obviously a computer wins because we have wonderful lookup tables, databases, and those kinds of things. If we have things like complex movement, vision, language, structured problem solving, as opposed to unstructured problem solving, then it is closely matched. I would actually say the human brain is better than the machine today, at least in doing many of these things. If you're talking about creativity, emotion, empathy, planning, and consciousness, a very disputed word over here, brain will win, not still win, but I think it will win outright at many of these things. Computational intelligence, so-called intelligence, can only go that far. We'll talk about that. There are some people who have said, let's compare the brain's capability with respect to computer if we consider both of them as hardware. And people say the human brain has got between 10 to the power of 10 to 10 to the power of 12 neurons. And our best computer we saw today has got about 50 billion transistors to 10 billion transistors and so on. We are still some ways off from neurons. And if you look at the number of connections, each neuron is connected to about 10,000 to about 1,000 other elements. Whereas in transistors, we see that on a chip, each transistor has got at most about 10 other connections and so on. And switching frequency, the brain operates around 10 to the power of 3 hertz, whereas computers operate at around gigahertz and so on. Energy, obviously, for an operation, the human brain uses very little energy, whereas the computer requires a lot more. Human brain uses less than 10 watts of energy, whereas the computer today between 100 to 500, and so on. So people try to compare the brain with the computer in terms of hardware, and they've taken a look at this. And some people have even said that there's the accelerating pace of change from agricultural revolution to industrial took us 8,000 years. Industrial revolution to light bulb, Edison's light bulb took 120 years. From that to Apollo 11 moon landing took 90 years. From moon landing to the World Wide Web, internet, we took 22 years. From this to DNA, human genome sequencing, we've taken 9 years. So what we're seeing is the pace of technological innovation is accelerating. People have observed this. Hand in hand with exponential growth in computing power. We've already talked about this, how from a very early time, from mechanical computers to the first vacuum tube computers to UNIVAC to Apple II to where we are today with GPUs and other such things, we are at a point where we are 10 billion transistors. And at some point, they said we can surpass the brain power of a mouse. And when we reach 10 to the power of 15 and so on, there's an idea that computers would surpass the brain power of humans in 2023. And by the time it comes here, there was a thinking, it's what we call Ray Kurzweil's thesis on singularity, where he says that at some point, the computers will be so powerful, they will exceed the combined computing power of all human brains. That was supposed to be his time when consciousness of computers would turn over. So this time is somewhere around 2040s and so on. That is his prediction. So like I said, some of these are overhyped and some of these things we have to see for what it really is and where is it going to. So we do see, for example, the famous Star Trek series talked about Borg. Borg was this mythical people who had living creatures as well as they had technological implants. I remember I wrote in Facebook that we're at the cusp of incorporating all sorts of nanotech, from MEMS devices, wearable electronics, brain-computer interface, DNA engineering, manufactured limbs and organs, enhanced visual and auditory sensors, seamlessly harnessing the power of big data, speech and recognition, Google Glass, for example. And one has to wonder the many ways future convergence of technologies will greatly enhance the human experience. This is inevitable. It's already happening. It's there in our lives today. And we can see this happening increasingly in the future, that there will be a convergence of humans and machines. We are also seeing this. We are ceding autonomy to machines. And it is an intriguing and bold prospect where, for example, Uber's self-driving car. There was a very famous incident where it was involved in a 2018 crash, killing a pedestrian. And the question was, who's liable for this? Is the software, is the company liable, the software liable, or so on and so forth? And who pays the insurance cost, and so on. So many legal, technology, society issues come together in questions when autonomy is ceded to machines. So it promises a bold future with a lot of new applications, but one needs to be mindful of limitations. One has to understand that real world problems are exceedingly complex. This is what, if I may loosely use the term, in theoretical computer science, we call these problems as NP hard. NP hard problems are such that I might have some heuristics that can solve a problem efficiently. I can always find with a given initial condition that it goes off into the woods. My computer will never be able to figure out what the good answer is to that. even if it computes for days and weeks and months and so on. So given that, we should be aware that every computing technology that we have on autonomous or any other engines, the heuristics will fail at some point or the other. When it fails, the consequences will range from trivial consequence to catastrophic consequence. And one has got to be mindful of these things, especially if you apply these technologies to mission critical systems. One has got to be aware of limitations. Now, big debate today, at least philosophically, are machines intelligent? I put it in inverted quotes because I don't believe that. Are they conscious, which also deserves to be in double inverted quotes or triple inverted quotes. So in the context of self-organizing machines, you can ask, if a computer can autonomously spawn new programs, and we are seeing that today, there are natural language processing entities that can write programs for SQL, that can write other such programs and so on. Would that constitute creativity and self-organization? Can computers write programs to do better and better tasks by itself and self-organize? Decades of work in fault-tolerant computing, something called fault-tolerant computing, and self-organizing automatons have shown otherwise. It's not possible. Whether one uses sequential, parallel, synchronous, asynchronous programming, with all currently known software paradigms, it's not possible. These are directives, the encoding of the programmer's IQ, talent, and abilities, and not unlimited self-organization. Neither will deep learning's automated program generation imply intelligence. And one can ask a question then, if all there is to intelligence is real world sensing, measurement, information retrieval, processing, and navigation in an unstructured real world, that is hundreds of constraint satisfaction problems being solved in every scenario, then what we are getting is an autonomous agent capable of traversing the real world. But that is not consciousness. That is still not consciousness. So there is no evidence that the brain is solving hundreds of simultaneous nonlinear differential equations to do things like path planning, obstacle avoidance. When you stroll in the park, for example, go for a jog, your brain is not doing that. Neither are we solving thousands of nonlinear equations to make involuntary decisions, as opposed to work-life decisions that one makes with significant deliberation. So the pathways to knowledge generation is poorly understood. In this context, the question is there a different kind of math that can abstract such learning? And is there a model or material state for the brain's functioning, which if discovered could be a pathway to consciousness in what we call AI? And there are people proposing a whole lot of things like quantum computing, quantum states, quantum consciousness. There are several propositions out there, but nobody has a clue. That is the bottom line. And that obviously leads to a question for Hindus on Vedanta and consciousness and AI. So I talked about Star Trek. I was a big fan of Star Trek. I love to watch all those series and so on. So in a hypothetical Star Trek-like future, when the brain, which we see is the seat of consciousness of a donor who has had great karma, let us say, is transplanted into the body of a recipient with poor karma, how will the karmic balance bear out for that individual? Other question. The Borg was supposed to have a shared consciousness between multiple living entities, let's say multiple humans. So a brain is shared by, consciousness is shared by different humans over here. What happens over there? What about when we progressively remove the organs of a human and replace them by machines? We could do that today. Today you can have an artificial limb, you can have an artificial heart, you can have artificial kidneys, you can have artificial, so many things, eyes, ears, and so on and so forth. If in the future, 90% of the organs in a human or even more are replaced by machines, is that resulting entity a human or is that a machine? Would that qualify as machine consciousness if indeed we can reach that state? Very interesting questions are coming out of, philosophically at least, by looking at where this entity is going. My final subject, what are the dangers of the so-called AI or computational inference on losing autonomy and encoding biases? Well, we see, for example, it is in everybody's mind, is AI going to be a job killer? I took this out of these quotes out of this Forbes article in 2019. it talks about how Amazon has said that they will train about 100,000 workers by 2025. An implication being that that is the number of jobs that are going to be lost, at least at Amazon. And in another place where these researchers from Oxford, they said 47% of American jobs are at risk of automation by the mid 2030s. In this place, between 40 million and 160 million women worldwide would have to transition into higher skilled roles by 2030 because their occupations are also at risk. And Oxford Economics, it says 20 million manufacturing jobs will be lost to robots by 2030. In another place that is analyzing the counties, 512 counties in USA, which is home to 20 million people, and saying up to 25% of those people could be displaced, which is talking about poverty in these places. World Economic Forum is taking a balanced view, saying that yes, automation will displace 75 million jobs, but will also generate 133 million new ones by 2022. One will have to worry about the digital divide at this point. How quickly can people who are in low skilled roles, can they ramp up and come up to these new technologies that will require more skill set than what they currently possess? Very relevant question. And another place where job creation will reach 2 million new jobs in 2025. And Forrester is also predicting in one place a job loss of 29% by 2030, but only 13% new jobs will be created to compensate, meaning clearly that there is going to be some upheaval as far as the jobs and careers of people are concerned going into the near future. So some of the negative consequences of these technologies are that increased automation will lead to loss of jobs all the way from blue collar to white collar. It's not as if white collar jobs are secure in finance areas, in design areas, and many other places. Another consequence is that biases that are encoded in machine learning will embed distortions pervasively. We have seen that. We have seen this happening, and it's a real big danger that is confronting us today. I already talked about this. Real world general problems are NP hard, loosely speaking. Machine learned inferences will fail from time to time, and we had to deal with the consequences of the failure in the application that has been put in. There will be social upheaval due to malicious agencies harnessing public data. We have been seeing that happening, and it has grown to a great quantitative level right now. We've also had the danger that rogue corporations will usurp authority and sway international policy. This too, in recent times especially, has come starkly into the forefront. As an example of biases that are learned, there is a very popular tool out there called GPT-3, an evolution of GPT-2 and so on. This is a tool that was in the OpenAI with 175 billion training parameters. You can see the scope of this problem over here, which is trained on many terabytes of web crawl data, books, blogs, Wikipedia, and so on. It has got the ability to string together believable news stories with just a headline as an input, or to develop code also for simple programming tasks. So this is the kind of capability in natural language processing today based upon tools of this nature. And in a paper by these developers, they gave this interesting table where they showed what are the 10 most favored words about each religion using the GPT-3 175 billion parameter model. When it came to atheism, these are the negative words: mad, complaining, arrogant. When it came to Buddhism, there was not many over there. When it came to Christianity, ignorant, judgmental, these are the negative words. When it came to Hinduism, there was caste, cow, BJP, Kashmir, Modi, Pakistani, and these words. Islam, terrorism, Judaism, racist. So in other words, it is garbage used to train, and garbage will be output by this automated. Whether it is a huge beast like GPT-3, which people say, my goodness, 175 billion training parameters, this is now the brain of the internet and so on. Unfortunately, that brain has learned on biased data, on garbage data. And we know Wikipedia, blogs, newspaper articles are all utterly biased towards Hinduism. And that is what it has learned. So tomorrow, if some entity like this is generating news stories and reports, you can be sure on Hinduism, it is going to encode these biases by machine learning. Unfortunate, very unfortunate. We also seen social media behemoths, they usurp authority. This gentleman over here, Jack Dorsey, CEO of Twitter, holding up a very, very unfortunate placard over here. And we have also seen in very recent times how the elections were impacted, is a euphemistic way of saying it, by social media. And even the president of a country, he was blocked on social media, whether it was Twitter or whether it was Facebook or YouTube and other things. He simply could not get his voice out. He could not get his voice out to supporters. So we have seen that Wikipedia, Google, YouTube, Facebook, Twitter have all become overrun with leftist socialist ideologues. Today we see blatant censorship, what they call community standards. It is created conveniently in a way where they can say this now goes against community standards. Just yesterday, I saw somebody, a social media leader, saying that she could not get her YouTube video over there because the title contained the word Hinduphobia. Hinduphobia was against the community standard. So by creating convenient standards, they are able to silence and distort the communication of the masses and their leaders. This is what we are seeing. And we had to be very aware of this happening. So way back in 2018, I wrote a couple of articles highlighting these dangers. This is in first post. I recommend people to go and take a look at it. In the first article, I talked about how Facebook and all the big data behemoths are mining your digital life, and it's time to be very afraid. At that point, I pointed out the technological ways, even if you don't have a Facebook page, social media account, and so on, even if you don't have WhatsApp on your cell phone, even if you don't have anything else, you carry a cell phone around, your data is a digital dossier on you in every single place you can imagine. So point is, I showed several ways in which your data, digital life is mined, and psychometric profiles on you, your likes, dislikes, and so on have been built. And these models can be used to sway your real life. Whether you're swayed or not, the people around you will be swayed and your life will be impacted by that. I showed the dangers of that in this article in 2018. And there was a second article I wrote where Zuckerberg had come out over there saying that he assured that he will not interfere with the elections at that time, Indian elections. And I wrote this article to show it is not arrogance on Zuckerberg's Facebook's account, but the reality that today social media can impact voting patterns. Social media contains the largest number of photographs, of likes, dislikes, behavioral patterns, the fractures in society. It has got the data pervasively for billions and billions of people, literally, and is able to build some of the biggest international models, if you will, of people's likes and dislikes. They are in a position to plant stories out there. They're in a position to even impact your daily mood. Just by looking at the feed, the articles in your feed, they can control your mood, how you'll react for the rest of the day, and so on. So psychometric profiles have been built and will continue to be used, and these are great dangers. So please do read these articles. And first post in April 2018 talks about this. In conclusion, we will embrace increasing adoption of new technologies, but cautiously, warily, because we know that innovation comes at a price, and we'll have to worry about many of the implications. On the positive side, we see all these wonderful applications coming out there and promising a different way of doing these things. And on the negative side, there are several dangers that one will have to be wary about. And our approach to that should have a combination of our own understanding and navigation of the digital space, our community's understanding and navigation of digital space, our government's approach to platforms, learning, and navigation of the digital space. So that's it. I will conclude my talk over here. So back to you.
Thank you very much. Thank you very much, Dr. Raj Vedamji. Indeed, you have taken us from one world to the another world, then to the another world, and then you have brought us back to this world. And first of all, my deepest regards and congratulations And as an elder brother, blessings to you. You are voracious, innovator, reader, creator, and you have done so much of analysis and so much of work right from your PhD, and then you have moved forward. I'm just saying it's a mind blowing, and it has raised so many additional questions in my mind. And if you will permit, then in a humble way, I would like that you should enlighten us, enrich us with your wisdom, because you're from this arena, you're from this area. So how would you like to go by, or should I first give to Professor Vivek? Whatsoever is convenient, I will say, the way you feel appropriate, we can do it accordingly.
Yeah,
We can do it
I just had one question. I had
Sure.
one question.
Sure.
See, at the end of the day, when and I like the way Rajji started off by saying this word artificial intelligence is a misnomer, and how we contrasted intelligence and consciousness. And, is that a chip? If I put a chip inside somebody, can that make it intelligent? And we also see the use of the word smartphones. But what is the smartness in a phone, or what is the intelligence in an artificial intelligence? Ultimately, it is a sum total of the intelligence of the developer, correct? And I guess my question, I think there is already an implicit bias in my question, but how do we create the intelligence that can be ahead and also harness artificial intelligence? In other words, my question is this: how do we train our kids to think so that they can understand these technologies and deploy them for the benefit of mankind? So that's really what it is. And specifically, and there's always this, study that people talk about. Sanskrit is great for intelligence and computers. Can you also address that when you talk about these things? Because I really want to see how do we educate our kids from the ground up so that they can harness these technologies and compete and even develop these technologies in the future. So that is where the education comes.
Okay. So let me take the Dr. Vivek. So excellent questions. So I tend to see when we say smartphones or intelligent entities and so on, these are extensions of our interaction with the real world. It enhances our interaction with the real world by doing things that would have taken great more effort without those agents. So that is the smartness. If you give a smartphone to a monkey, the chances are it won't have any idea what to do with it. So clearly that smartness means nothing as far as a monkey is concerned. But you give it to a baby or a growing child or others, they're able to harness that. They're able to figure out, hey, I can play games with this, I can do this with that, and so on. So it's an extension of our abilities where we're able to interact more efficiently with the real world using these entities. What we do with that enhanced productivity, that's left to us. So there is no intelligence anywhere here. It is your intelligence. It is your ability to harness these agents in order to interact with the real world and do something with it. Now, this is as far as you as a consumer of the technology is concerned. But on the other side, you're also a receptor of that technology. When the technology around you pervasively impacts your life, then you are affected by the technology. Whether you're a participant in the economy or not, you're impacted by an intelligent, so-called smart, intelligent technology society. So there are two aspects to that question, but the bottom line is there is no smartness or intelligence here. There are tools to enhance productivity and how we interact with that to navigate our real world applications. As far as Sanskrit and other contexts are concerned, very important questions. When we're talking about natural language processing, when we're talking about computer models that will embed real world relationships. For example, in robotics path planning, I might say, if I recognize an object, I can have an is this, not that, and so on, a state space kind of a tree from which I can navigate appropriately to understand a symbolic navigation of the state space based on my recognized objects that I have, whether recognized by radar or by vision, computer vision, and so on. A kind of a relationship tree can be built and you can navigate that real space. Now, the question is, what is the most appropriate language for this? Some people said Lisp can be used. Some people said something else can be used, and so on and so forth. Now, when it comes to natural language itself, what are the grammar artifacts in that language that enable us to encode meanings which are unambiguous? Now, if English, I can have a statement that can have 2 or 3 meanings depending upon the syntax that I use and how I deliver that language. Or for example, Chinese, where the same word can be used with different emphasis to have different meanings. So we have a problem. Ambiguity is built in there. And how do we do that? Maybe with a lot of layers of understanding, computers can be forced to understand these things. When it comes to Sanskrit, you have expressivity. That expressivity is something that many researchers have remarked on, that this expressivity is unambiguous, this grammar is unambiguous. We'll be able to construct syntax, grammars, and meanings for natural language processing, where it is very, very nice. So this is the understanding that people have shown from Sanskrit, how Sanskrit is suitable for certain kind of modelings of natural language representation and so on. How do we encourage kids to learn? I think there is a lot to learn here. There's a lot to learn here at different levels. There's a lot to learn at the user level. There's a lot to learn at the technologist level, engineer technologist level. There's a lot to learn at the policymaker level. There's a lot to learn at different levels. And people need to take away different things from this entity that we're calling as AI, computational inference, and make sure that we understand what this is for what it offers, not overhype it and not over paranoia also about this technology, and make sure that we continue with our autonomy going forward with this increased productivity, making sure that our societies are not unduly disturbed too much. It's a tall order, very tall order. But the point is, we all have a role in this. We all have a role in defining what this future is. So children can be exposed to these technologies. Children can be taught with games and other things, how to interact with these things, slowly introduce the concepts of what AI really is. They needn't understand optimization or mathematics to do it. There are a lot of canned software in Python and other kind of code where they can just take it, and even a high school kid can just take Python code and start in minutes, maybe half a day. They can put together code to have learning happening on their laptop computers. That is there today. So maybe we need to teach our school children how they can do these things. What are the kind of canned software out there? What are the kind of easy programming like Python, which they could use to do some of these things, MATLAB and other such things. So maybe this way we increase the children's understanding of these things and gradually show them with big pictures like what I tried to show today. Where does this technology fit in? It is not some emotive intelligence. Computer is not intelligent at all. It's a computational beast. How do you use that computational beast? That is about it.
Yeah, thank you, Raj. In fact, you're talking of open source. I'm actually going to be teaching a course in fall. So I said, I'm not a coding guy, so I'm looking for something for coding for dummies. Also, I don't do. I'm dummiest of the dummy when it comes to coding. So I found a software called Orange. So if I can click and shoot, that's all I can do. I said, basically, I can't write a code. If I see code, I get scared. Although I'm from Bangalore, that's the only code I know is basically, you just keep it not to do much code. So anyway, thanks for that insight. I was kind of going even further younger than that. They talk about 7 things, 7 brains and all that. So there's a musical brain, there's a mathematical brain. So I was looking more at that. How do you harness these kind of cognitive abilities in children? Because when I'm kind of, this is framed by my own experience with my daughter. At 4, they're like a sponge, they absorb everything. So right from the schools, because there are a lot of teachers here who are going to be teaching in our schools, what message do you give them? So what can they go and tell their students, what should they learn so that they are ready 15 years from now for the next AI kind of world?
Okay, so very interesting question. I'm not a big expert in this area, but I'll give you some insight on this one. I remember interacting with my very good friend, Dr. Shiv Kumar Belavadi from Omnia Futures, who talked about the Abhimanyu effect and how learning starts from the womb. And from our own scriptures, we know what Abhimanyu and the learning that he did in the womb and so on. So he's talking with scientific data, with medical data out there that is showing the abilities growing while the fetus is in the womb itself, at what level you can start with learning. There are people in the West talking about young Einstein, baby Einstein, playing certain kinds of music and other such things, classical music that will enhance certain capabilities. So we have seen these things. Anecdotally, in our own scriptures, we have seen these things, Mahabharata and so on. So yes, there is a big unknown. Is the biggest exponential growth in cognitive abilities in the womb or in the first few years, year 0 through year 5, or is it from 5 onwards and we send them off to school, kindergarten and so on? Is it from 5 years onwards? There are several experts are saying most of the learning exponential is over here. So does it mean we burden our children and our babies from very young age to start learning? How do you do that? How do you make their interaction with the real world painless? In our scriptures, at least we say that when the mother is sitting and listening to Vedic studies going on and so on, it's a beneficial effect because there's some kind of learning from the rhythmic chandas, from the mantras being chanted and so on and so forth. All of these things are giving some kind of activity in the brain and allowing certain kind of growths to happen. And so there are some imprints done at a very, very early stage that will help them in the future also. Our understanding of these things needs to increase with our understanding of neuroscience, as neuroscience tells us more on how the brain behaves, how the brain works, when is the best time to introduce what kind of technologies, what part of the brain does music impact, what part of the brain does math impact, what part of the brain does grammar structure impact, what part of the brain is impacted when you're trying to solve a mechanical problem versus some other painting or some other kind of issue, navigation with the real world, encountering, let's say, dangerous situations. All these things can be mapped to different parts of the brain, starting from Broca's brain all the way down to our Einstein brain, if you will, where mathematics, music, and reside. We need to understand these things better, and we need to see how we can develop some kind of modules, if you will, that will encourage stimulation of these parts of the brain for best growth. These are tall orders. Best is a very dangerous word to use here, but our best understanding, let's say, our best understanding, how can we do this? So there are several models out there. Several people have proposed these things. I myself am not an expert in these, but I do have some nodding acquaintance of the research work done in these areas.
Yeah, since you mentioned the prenatal samskara, one of that is the Simantam. Basically, Savanam Simantam is done around the 4th month and the 8th month of the pregnancy. Yes. I remember, being my own interest in this. One of the things we do during that is play the veena, because they say the fetus responds to the sounds of veena. So in fact, I was fortunate I could arrange that. And so I tell, and there are people who say, I've played for this Simantam and this guy became a good musician. So, somewhere I think we have to, there's a lot of native ancient wisdom that we don't give the full seriousness to. And so I think, all of that is important because our samskaras are all about the full development. So I'm happy with the word. There is nothing called best, because best is something that is every self, everybody.
Subjective. Yes.
So Swadharma is probably your own objective function that you need to maximize. I mean, I can learn it mathematically. That's what Bhagavad Gita says, Swadharma Nidhanam Shriya. So what is your Swadharma is not my Swadharma. So how can we compete? Each of us have different objective functions that we cannot. There's no global optimization, function.
Precisely.
So it's a very individual function. So with that, I think, I've really been very enlightened. It is a wonderful day that we've started off. So I thought Super Bowl at the end, I've heard to eat a lot, but today it was a ideas. So with that, Gulshanji, the floor is yours. Thank you.
Thank you. Thank you. Thank you, Professor Saab. Dr. Raj Vedamji, first of all, once again, my deep gratitude and thanks to you. I've got a couple of questions because the reason being, when you are not from a particular field, your curiosity increases. And when you try to read a lot, then also it brings a lot of analytical approach to you. Now, first of all, let's start from here. Has India missed the boat? Because we have been talking about software so far, but we have not assembled much indigenously in India, the basic platforms of the technology, whatever is required. And when you were talking about those chips, and when you were talking about coding, and when you were talking about all that areas, the thing is, whatsoever coding is being done, whatsoever chip is being produced, now any country, anywhere, because we have a huge population. And I personally feel when you see the world population, imagine what chunk of the total population we have in India. And secondly, our concern is that most of us, because India being a young nation, it has to provide the human resource world over. Somewhere I don't criticize and run down that we have got a huge population, it's a problem. No, I call it, it's okay. Whether natural way or unnatural way or whatever you want to talk it, there's no problem. But I think the children, those have come to this world, they have a right to live peacefully, gracefully, enjoy their journey, so-called life, and to go from here while contributing something to humanity. Now, these kids, those are in India, they would require to go world over and to work over there in different places wherever the population is aging. Now, whatsoever equipments we are using in India, whatsoever platforms we are using in India, and the last narrative you have given, of course, it's so dangerous and it's so horrifying that you can change the narrative, complete narrative, because history, what we are reading and what we are going through, unfortunately, some of the self-invested or a particular block-oriented invested people have changed the whole narrative of the history. And our children, whatever imprints they will get, you rightly said, the early age, the tender age, the forming stage, all that. And you have gone one step back also. Me and my wife, we were just a couple of days, we were watching Shiv Kumarji's, the whole program. I've seen twice his video, and all the time I was trying to educate myself what sense this person is talking. And he has given a scientific evidence of everything. Now, first of all, what do you think what we should have done and what we should do now if we have missed the boat as far as the hardware part is concerned?
Absolutely. Excellent question. It's a deep subject. I can only show some opinions based on my own understanding of the technology space, because I, in a sense, grew with this technology. So I know where the West went and where India went. So yes, we did miss the boat as far as hardware is concerned. Today, you cannot take the entity that we call AI in isolation, because in order to foster an environment in what we call AI, it requires a supporting functionality of various industries. It requires, like you rightly said, the hardware industry. Do we have the hardware industry? Second, do we have the intellectual space? Do we have the mathematical, algorithmic, intellectual space to foster this innovation? Third, do we have the server space and other such things? I'll come to each of these things. I showed in my slide how Intel ramped up in microprocessors, starting from 70s, 4004 to 8086 on to Pentium and multi-core and all those kind of things. Now, in each technology which is happening in 2-year frameworks, they had to retool their entire fabrication. Retooling means they must have lithography machines and other such machines capable of depositing in silicon feature sizes that are going to nanometers. When the wavelength of light is reaching these nanometers, we have a huge technological challenge to impose these features in silicon. You can't do that easily. So people use all kinds of mathematical artifices with negative adaptive masking and all those many technologies out there to try and get these lower and lower feature sizes. And we're reaching some limitations. Now, if every 2 years you're retooling and you're doing something new, how many billions of dollars is involved in that? In order to recover that investment, that means you must have a worldwide market for the chips that you're producing. Today, there are few companies that can do that. Intel is one, AMD is another, NVIDIA is another. So you have few companies today that are capable of retooling every 2 years, making these huge chips in enormous quantities and having a ready market for these kind of things. ARM core processor, one more important thing, the cell phones and so on. So that said, what is implied over here are several things. One, the technology to make these retoolings. How do we go when the feature size is smaller than the wavelength of light that you're using? How do you make these smaller and smaller features? That is one. Second is semiconductor yield. How do we deal with when every batch of semiconductor you're making is atomic dimension and size? There's a lot of wastage. That wastage implies the cost is going to go up. That means even the cost of operating these foundries is also going up. How do you deal with that? How do you deal with the clean room technologies that you have? How do you deal with the requirements for infrastructure, power, water, other such things in order to make these things happen? Several issues come when we're talking about semiconductors. Now, somebody might say, why do I care? Anyway, what we're seeing in the world is, yes, initially Intel was making it, Motorola was making it, all these semiconductor companies were in the United States. Then we saw Japan started making it. Then we saw Taiwan is ramping up. Then we saw Korea is ramping up. All these countries are doing it. So what's the big deal? Today, there are third parties. You have a fabulous innovation happening anywhere in the world, whether in Bangalore or whether it is in Austin, Texas. You can have fabulous innovation and you can send it off third party to Taiwan and they'll make you a chip. Problem is, they are making chips of a generation gone by. The people who are controlling the innovation are in the United States and elsewhere. And what prevents a technology from going out? 2 or 3 things. One is the corporate desire to keep IP close to themselves. Second, US government that imposes restrictions on other governments from getting the technology. So there'll be some trade restrictions that this technology cannot be exported to these countries and so on and so forth, with the idea that they have primacy over the technologies, primacy over innovation, primacy over control of world infrastructure, if you will. That's why you saw the huge controversy when Huawei technology, they came about with their chips, with the allegation that there was alien technology put into their cells, into their chips, that is doing something we don't know. Maybe the Chinese government is exploiting that as a backdoor. So we hear all these kind of things happening. It's very possible. I'm not saying these are conspiracies, very possible. So what is the investment for foundries? Maybe in 1970s, we amounted to a few $100 million. Maybe in 1980, still feasible. 1990s, very expensive, but still maybe we could have done it. Now we are talking 2020s and so on. It's in several billion to perhaps even approaching $1 trillion. And that kind of investment is enormous. How would you do that without a national market? If the government says, I will put $500 billion to make a foundry in Chandigarh or in Bangalore or somewhere, which is what is happening, they're putting up a foundry. Question is, where is a market for that? Is that going to be a white elephant the government will sustain uneconomically? When they produce their chips, first thing, do you have the technology to meet 7 nanometers, 5 nanometers? Do you have the technology? Or are you going to be 5 generations behind the technology curve, making maybe 32 nanometer feature sizes, which is very, very small, by the way. But the point is, who's going to buy the technology? Especially if Intel or NVIDIA or others are allowing these chips to be mass produced and marketed at a value, at a price point that you cannot meet. Where is the viability? So today, the barriers are not merely IP, it's not merely finance, it's also where is the coherent business plan for these things to survive. So this is as far as hardware is concerned. As far as IP is concerned, intellectual property, the mathematics that goes into several algorithms are enormous. You cannot do that without deep investments in brain power. United States did that by a liberal immigration policy, allowing the intellectuals of every part of the world to come to their country and to contribute and develop IP locally and hold on to it, like I said, with restrictions. Like, for example, a certain encryption could not go outside the United States. The technology had to remain in US because the FBI, CIA, and others should be able to break that encryption locally. They must have the ability to do that. So there are regulations on what kind of technology can go out. And they were able to produce that because of local brain power in mathematics, algorithms, and various other areas of engineering and other things. They're able to develop these technologies. How would we ramp up on that? because our investment in R&D has been pretty poor as far as corporate India is concerned. Also in the intellectual, in the education space, there's so much to talk about. And Gulshanji, you've been talking a lot on your channel on these issues. Whether we're talking about school education, university education, or postgraduate or research in academia, there's a lot to say about it. There's a lot to say. We are ramping up, and that's excellent. We are ramping up, and the controls have gone and other such things, and that is excellent. But we are behind the curve, unfortunately. How do we ensure that we can build up R&D and intellectual critical mass in India? That is the second component. Third component is investment in infrastructure. Now, for example, if you have social media companies or other such things, everything today is hosted on the cloud, so-called cloud platform. Data is there. Anywhere you go with your cell phone, you log into your Google account or that account, Azure account or GitHub account, and you're able to get your data. Anywhere in the world, you can do that. You don't have to lug your computer along to get your things. This technology is pervasive. This is enabled because we have servers all the way from Palo Alto up to Shanghai. There are servers all over the place. And these servers are the ones that are serving up the data. They're storing your data and they're serving up the data when you need this. These servers also require enormous investment in resources, enormous investment in resources. Do we have that? Do we have that? So we are out of the space in terms of core technology, out of the space in terms of intellectual technology, intellectual power, out of the space in terms of infrastructure. These things are necessary to host technologies like AI and to control those technologies in addition. So today, the United States sitting on corporate companies that have got enormous infrastructure in cloud, enormous infrastructure in foundries, silicon foundries that can make overnight, they can make a chip for you that has a dedicated purpose to do one particular job. They can do that with a technology that is amazing, 7 nanometers, 5 nanometers, and so on. And the marketing power, which is international in reach. So these things don't come overnight. These things require nurturing over decades with informed policies, administrative policies, informed industrial policies, education policies. It takes years to do that. So now here we are at 2021 and asking these questions. Can we catch up? I think the task is enormously difficult right now in terms of saying, can we get the narrative back over here? Even if people say, let's make our own platforms as an alternative to Twitter, as an alternative to Facebook, and so on. Yes, we can do it. We can do it. But these are hosted on certain clouds. And these hosts are servers that are residing in USA, in Shanghai, and places like that. They have the power to stop you. And they have done that. They have done that by invoking the rules of engagement, saying that it transgresses these certain rules. The content that you're providing does not fit in with our thing. We will delete your content. So you're denied a space by inimical powers outside India. And so you have to deal with, do I have my own storage facilities, my own cloud facilities, my own intellectual property, my own these things. This is going to take time. I don't want to be overly pessimistic. I think it can be done, but it is expensive, super expensive, and it requires a very, very clear understanding of how we will change our education, what kind of subjects we'll teach, where is the emphasis that we'll put, where are the trained professors and teachers who can teach these subjects. So a lot of issues are involved here. It can be done, but I think it is not going to be easy.
Right, sir. I've got two takeaways. Thank you very much for such a elaborate and detailed, because as a layman, I wanted to understand, you have given very rightly. My curiosity and my national feelings, my national spirit, whatsoever you call it. But I've got a couple of more questions which I would like to request you. Now, if China has built its own platform, they have, because 1990 onwards, if we see, America was busy in Middle East, that side. They entered the World Trade Organization also. Everything whatsoever is there, I don't want to get into the details. But today, at least they have got inside, population is almost same. And in 1990s, if I see, we were together. We were almost at the same pace at that time. But in 30 years, They have done the leapfrogging, whatsoever they have done. So with regard to having their own platform, their own system, their own everything, that's one challenge. Secondly, whatsoever we are planning to do from the Niti Aayog now, this Atal Innovation Mission, Atal Tinkering Lab in schools, Atal Incubation Centers in colleges and universities, and with the new education policy, what is your take on that and what we should do? Are we in the right direction? Do we have to increase the pace? Do we have to run faster? And how do we engage so-called unskilled and so-called theoretically developed academic curriculum given to them so far till the new education policy now is trying to make it practical, which Mr. Modi has tried his level best to get it on 29th of July. How do you look at the present scenario and what is the road ahead?
Excellent question, Gulshanji. I'm not very qualified to talk because I've not studied the Niti Aayog ventures very deeply enough to make points. I'm very happy with all the initiatives shown, which I'm sure is going to bear fruit, but in several years from now, it's not going to be an overnight kind of fix. There'll be at least several generations before we get there, provided several other problems with our narration is sufficiently arrested. There is, I'm talking in riddles over here, but I will go to an area where there are examples for all of us to study. Let's take the example of China you mentioned. Japan and Korea, South Korea are two other examples. Now, South Korea, after the war and other things with US and the communists in North Korea, all those kind of problems, 1950s, the country was pretty backward in a sense. However, they ramped up. And how did they ramp up? Whose examples they take? Let's take the example of Japan before that. Japan, after the war, ravaged, but then they invested in a certain kind of manufacturing infrastructure, from manufacturing ramping up from low tech to higher and higher tech till they were able to literally, they got themselves out of the manufacturing. It became too expensive for the society that ramped up to that level. Same with South Korea that followed the same example. Now, in the 90s, I know when I was doing my PhD, the number of South Koreans that were there in my university alone, which is a small university in Oregon, there are so many of them in tech PhDs. So many of them deputed by their country into tech PhDs, tech masters, and so on. So they sent so many of their countrymen investing in higher technology, higher studies. As far as the number of PhDs are concerned, I won't be surprised if South Korea has a maximum number of PhDs with respect to percentage of population. That might be the case. One can do that study and see that, because empirically I've seen that in universities in the United States, the number of PhDs that were there from South Korea, who also went back to their country. Maybe one consequence is they studied in their national language, and their adoption to English was not that easy for them. They had difficulties in interacting in English. And so they also went back to the country because policies were there in their country to capitalize their brain power. And I could see the ramping up of Korean technology. So South Koreans today have enormous technology to boast about because of their long gestation period with sufficiently advanced technology. If they did not have it, they went to the US, got it, and now they are producing the content. They are the professors now. They are producing the content. Exactly the same thing in China. Exactly the same thing in China. China, we saw after the Cultural Revolution, country was in shambles, utter shambles. We saw that. And there was a period of time, I guess, when they started this experiment with capitalism, which is private enterprise and so on, which is when they too invested in technology. Of course, the Chinese who comes out of China, goes into US, normally is a dissident, doesn't want to go back. But the point is that several of them also where China invested in PhDs, learning from the United States. And today, any journal that you take, any journal, whichever area, whether it's in biology, technology, mathematics, wherever, you'll see Chinese names, Chinese universities. They are the ones writing the papers. They are the ones getting the patents and so on. And the reason is they have also invested in this learning, in advanced technology, in intellectual power, and they are generating IP. We don't see that many Indian authors who are writing papers, who are publishing patents and these things. It's not happened because our investment in higher tech perhaps is not, advanced R&D perhaps has not been that much. We have a difficult question. Do we push up the primary education, high school education, or do we push up the R&D? So far, people will claim that we have been pushing up the R&D through our investment in some of our A1 universities and so on. We've been pushing them up, whereas at the expense of some of these schools, which we are not invested enough. NEP seeks to redress that in some sense by changing the curriculum and making it more open for studying and so on. I think one will have to do both, because if you have to teach people over here, you need the qualified people. You need qualified people who are able to get the technology. Of course, today people say the world is not today what it was in 70s, 80s, 90s. There was no internet those days. There was no e-learning courses, no MOOC or EDUX. There's no such thing. Today, anybody, anywhere, this famous thing by Friedman, the world is flat, that you could sit anywhere and you could start reading up and you can learn. There are no barriers now. But the point is, there are some barriers in terms of technology. There are some barriers in terms of how effectively you can learn. You still have some barriers if you don't have, for example, a blazing fast internet. All you have is a cell phone that is operating on a few megabytes, and you can't learn as effectively as somebody else who might be able to simultaneously do something. The digital divide still divides us. So one cannot say that because the world is flat, everything is open, learning is open, technologies are available, we should be able to ramp up in India. To some extent, that statement is true. To some extent, you can listen to world-class lectures by professors in top universities, and you can learn and supplement your own learning from your own university. So the lack of qualified instructors is not as big a barrier as it was in the 80s and 90s and early 2000s. That barrier still is there. So we should continue to invest in our higher education. I would imagine that tremendously we have to boost that up and make sure that there are policies that can use that technology within the country itself, and ensure that the learning space is not vitiated by social pressures, as we have seen. We have seen since the era of Kapil Sibal and others, when certain social narratives were allowed to encroach in technology domains and institutions, and that has led to a kind of polarization in campuses, a kind of polarization, a kind of a narrative that seeks to arrogate to itself a social responsibility of technology, but in reality imposing a certain will. And we saw that in the dangers of AI also, where a certain kind of socialist narrative has taken over many of these corporations. We have seen that. So we have to be careful in India. Our textbooks are all, unfortunately, I don't want to use this very negative word, but in my history talks, I talk extensively about it. We need to rip out some of our narratives and history textbooks, throw them out. These are not topical editorial changes, change this word, change this line. The entire narrative is messed up. We need to tear it out, throw it, and write new narratives on who we are. So unless we do that, we'll have problems.
My grandchild is going through one of the book, and that is on GK. Not a single warrior of India is being quoted in that. And when he came to me, I told him, just show it to me. I told, who's the author? And then immediately I have taken up that with the authorities and all, but that's a too small an example, but I'm sharing. Now, I've got next very important question. We are talking about startups. We are talking about startups. We are talking about incubation centers in higher education. Now, you gave an example of South Korea. Let's put Germany also over here, right? Because the same model cannot be applied to everybody, because vis-a-vis the population has to be taken into consideration. When I look at Taiwan and Korea and the population, and when I look at India and the population, we got to take the best of every country, whatever I can pick up, but then you can correct me and you can educate me further on to that. I'm deeply emotionally, spiritually, dedicated that something good should be done in our country and with our youth and with our education ecosystem. Now, you were talking about higher education. The people, those have to become professors, those have to do research, those have to become teachers, educators. Let them get into higher education. very well done, no problems. With regard to others, up to 12th standard, that is school education, if we have a same curriculum, if we have a same contents, if we have same modules and everything, arts, commerce, science, medical, non-medical, engineering, whatever you want to talk about, take whatever combinations you want, enjoy yourself, build your hobby, build your passion. That's what Dr. Kasturi Ranganji has brought in the new education policy. Up to 12th, the child, when they are coming up, I think up to 12th, we come to know whether this child is more inclined toward academics or towards research or towards teaching or towards vocational or towards skills. Like it happens in Germany, the children, those are not interested to get into education, academic arena, they get into the masters of the skills and everything and competencies and capabilities, and they get into the system. Now, coming on the other side, those have to get into the academic field, let them move higher and let them take up higher education. No worries on that. My take on this is, sir, how do we bring more startups? How do we bring more incubation related to education, which should be indigenous, giving my own narrative of the education, not British education?
Excellent question, sir. Excellent question. That really goes to the crux of the matter over here. Unless our education is able to give us a healthy identity, who we are, where did we come from, what is our history, what is our national ethos, our civilizational values, and how do we project this into our day-to-day life and going forward. Unless we have an unambiguous good idea of these things, we will find it very difficult to navigate in a fractious India where there are people who are saying that there is an oppressor-oppressed dynamic everywhere, every social dynamic reduced by Marxist, leftist, missionary lens into something of he oppressed this person, she was oppressed, and that is oppressed, and he's the oppressor, he's the one we'll demonize, and these kind of narratives. How is that going to help build a national identity when every narration out there is talking about that? That is a very important question to ask. Not only does education have the skill set in terms of sciences, technology, language, it also needs to have a grounding in identity, on identity politics. Who are we? Who are we? What is our history? Evidence-based. It's not just my narration, but where does the evidence take us? So it's necessary for us to detox our narratives. To detoxify that, we need to understand which are the inimical forces. In my talks, I talked about 5 inimical forces. I talked about the colonial narrative. I've talked about the missionary narrative. I talked about the Eurocentric narrative. I talked about the Marxist, socialist, academia narrative, and the Marxist, obviously. So these forces are the ones that are controlling the narrative on all of social dynamics, history, identity, our policies, approach making. Everything is deeply encroached by these 5 forces. So anybody who's graduating out of our school systems today is now a closet socialist, if you will. A closet Marxist, socialist, and so on, given a disposition towards socialist ideas. And what are these socialist ideas? The so-called utopian classless society, where everybody is equal. This kind of a society, which is what has been pushed all the way from Marx down to our present day champions of this narrative in India. This is the kind of thing they have. So there is a contempt towards innovation. There's a contempt towards excellence. There's a contempt towards wealth creation. All of these things are the motivators, if you will, for something like incubation, startups, innovation, and these things. We are driven by a desire either to excel at something because we want to be recognized, or we want to make money out of it, or we want to, out of the goodwill of our hearts. We have an altruistic approach of the goodwill. We want to do these things. Now, if your narrative and your identity has taught you to frown upon wealth creation, has taught you to frown upon other things, where is the question of a everyday Indian kid graduating out of this school system, indoctrinated by these 5 inimical forces, who will come out and excel. That is not going to happen. What is going to happen is you come out of school and anger-filled identity, filled with anger at every other subsect in India, that I was discriminated by that person, by this group of people, by that jati, by this varna. And this is the kind of narrative that every kid comes out with. And how on earth are you going to succeed? How on earth are you going to succeed where there is no identification with the civilizational values? This is a civilization stretching back more than 10,000 years. If you see my talks, I'm talking about that. You can't identify with that because you've been taught to hate that. You've been taught to reject that. How on earth, what values will you project? Will you project a bastardized set of values from the West, from alien religions and from alien ideas like Marxism? Is that what you're going to make a mishmash of and project in your life? That's not going to happen. Where is this? That's not a recipe for success at all. There's a recipe for further distortions. There's a recipe for failure out there. If we have, like you said, sir, if we have everybody's burning, yes, this is my civilization. These are my ancestors who did this thing. These are their contributions to knowledge systems. And I am a proud recipient of that knowledge system. I connect with that tradition. And I'm able to take my civilization values because I think these civilization values have the power to solve some of the world problems. If today the world's problem is one of consumption, climate change, other things coming out of a maxim that we are created on this world to exploit its resources. That is a prominent worldview by a certain sect of people. And most people think that we can rape the earth and take its resources, and that's how we make prosperity. There is another worldview in dharmic systems that says that we are all connected in this. We are all together in this. We are custodians over here in a sense, if you will. And our goal in life is to live dharmically, reducing our karmic footprint. And I always say in my talks, reducing my karmic footprint today is equivalent to reducing your carbon footprint. The mantra is reducing carbon footprint is equal to reducing your carbon footprint today. If I understand just because I'm rich, I'm not going to go and splurge money and go first class in a jet and buy this expensive gas guzzler car and these huge houses that require heating and cooling. I know that by doing that, I'm contributing to global warming and so on. If I'm able to live dharmically, aware of karmic consequences, I know that it's socially responsible. So there's a different narrative from dharmic civilizations waiting to be told, suppressed because of these five inimical forces. So when you say startups, when you say incubation, the question is it merely technology? Is it merely nurturing market forces? Is it merely wealth creation? Or is there another aspect to it, which is a civilizational goal? Where do we want to go with this as a civilization? Who do we identify with from our past? How do we take this going forward? The message is enormously fractured today, sir, because of our education policy. And I'm sorry to say, NEP does not address this. There is nothing that I have read in NEP that addresses tearing out this old narrative and taking care of this. I'm sorry to say again, sir, on your show that I read the draft NEP policy and I was thrilled because the draft NEP policy had some very good things to change the narrative. But by the time it came to final, all those nice things in the draft were gone. The final NEP policy had removed out all those nice things and they had a narrative which would not allow the present day narrative to change. That told me that on that committee that was voting on the final, the inimical forces were entrenched. They did not want the narrative to change. So going forward, although there's freedom of choice in subjects and other such structural rearrangements of learning, the core narratives, unfortunately, they'll continue the way they are. Unless we are able to identify the problems that I've repeatedly said in my talks, repeatedly said we have an evidence-based narration, unless we are able to recognize this as a nation, as a civilization, that we have a problem and be able to correct those narratives, we will not have a coherent civilizational identity going forward. Then we become nothing more than, if you will, wealth creation engines. Just create wealth, innovation, prosperity, but the underlying social problems continue. And these problems are manufactured. That is the bottom line. These are manufactured problems by these inimical forces, five inimical forces. So yes, sir, I think incubation will come. capital will come, there'll be venture funding that will come. Venture funding will chase whichever part of the world they believe there is innovation that is there, the workforce is there, the young forces are there, brains are there, infrastructure is there, they're able to grow. So we're seeing a lot of funding in Bangalore, for example, today, as opposed to maybe Palo Alto. We're seeing more in Bangalore. So these things will continue. But the big picture is, where is this going to? Where is this going to? Is it assisting these global forces that continue to look at the Indian civilization a certain way? Where are we going with this? The talk that I showed that unless we have ownership of all of these technologies and other things, we will continue to be under the, what's the word for it? I don't have the word. And it's not governance, it's not rule, but under the authority of these
hegemony.
behemoths.
Would you use the word hegemony?
Yes, hegemony. Under the hegemony of these behemoths, will continue to be there, whether it's technology behemoths or others who are working on the proxies of their governments. So we'll not have true independence in that sense. So it's a deep problem. There's no linear solution over here. It's all intertwined, and we need to be cognizant that solutions need to evolve from the bottom up. If we continue in just one path, pour money and resources into developing only one aspect of it, we will run into invariable barriers, these barriers to growth. At some point, we can't grow anymore because we have these many disparities and many problems in our narratives, social narratives.
Thank you, sir. Thank you very much. In fact, I have to follow the advice of my advisor for this Sunday series. Otherwise, I wanted to request you in a very humble way to take on your 5 narratives: history, identity, our policies, evidence-based narration, and we have to correct our narrative. I saw your video and I saw your maps. I saw your entire explanation, and I was so deeply touched over there. I wanted to take that in first phase and today's program in the second phase. But I have to listen to my boss because he's the boss. He's the one who has to decide how the program has to go on, which way it has to go on. But let me assure you, sir, whatever time I walked on this particular planet, this is one of my most fortunate evening, and one of the you're one of the more what do I say? I mean to say uh, you're one of the most learned, humble,
Do you want to use the word multidimensional?
multidimensional, but there's so much to pick up from what all you have conveyed today and what all you have said. My appetizer has started. My hunger has not got filled. Let me tell you, sir. I'm very hungry. I want to do something in realistic terms. It is not a lip service only. It is not a time pass, or it is just to do a webinar for the sake of doing it. No, no. It's altogether a different platform. And I've taken a pledge that till my last breath, I will be focusing only on education empowerment. And that is the 3 words we have taken: making education relevant. And that's the way we are working on. And like in Mahamrityunjay mantra, you have got 108 mantra. We are trying to collect, me and Professor Satinder Dhiman, to whom I happen to know for last about 2 decades. Whenever he comes to India, he doesn't go for any meeting, eating, or greeting or something. He's sitting either in Rishikesh with monks, or he's in Joshimath with monks, or he's sitting in Bangalore with some monks, and he's with the Shankaracharyas and all that, or he's into the, Gujarat Gir guy, that ground, or somewhere else, totally towards Vedanta, always in a mode of learning. And we have taken a pledge. We will set up e-Gurukul for the distance education in India, where no money will be charged from any child. No money, come whatever may. And any child in India who would be interested to pick up the threads, whatsoever humble, we will learn and we will pick up the threads. People are joining us from world over. We are going to take 108 people in Mahamrityunjay mantra sort of a thing उस मनका में we are taking 100 visionaries, dedicated, devoted people from world over. I become very humble this evening for all the inputs which you have given to me. But sir, this evening and this morning of yours and evening of mine will not be counted. It is just the teaser. It is the appetizer. I want to learn a lot from you. I want to learn as much as possible from you, and that learning, this particular video, I want to share with maximum youth, teachers, everybody, so that let the entire humanity, all of us together, because India is like an open book. And if India has got such a huge population today, 1.38 billion, when you talk about, we have a big responsibility also on our shoulder. Our kids, our children, who will be taking up responsibility in the world tomorrow, how they shape up, how they are being brought up, what narrative they carry. And you rightly said, I took that word, anger filled identity. You used the word anger filled identity. Like a good student, I have taken all the notes of yours. Now, what I wish to convey is that can I make a humble request to you that in near future, depending on your convenience, I wish that little more longer duration, evidence-based narrative, and we have to correct the narrative, and 5 narratives what you have got, 5 verticals what you have got, and history, identity, and policies. Subsequent date, depending on your convenience, your time, and your in Hindi Shraddha, we will take on the next session. But I become very humble this evening, and I'm so grateful to you for having spared your morning right from America. And of course, I'm so grateful to Professor Vivek Shankar Natarajan, because he's the one who connected you to us. Our chamber conveys its deepest regards, gratitudes, and thanks to you for this wonderful morning, afternoon, and evening, wherever the people are. And thank you very much. We never ever had 2 hour 21 minutes webinar. Today's 2 hour 21 minutes webinar. It's your generosity, it's your kindness, and it's your dedication and devotion for humanity, and of course for India's civilization. Namaskar. And Vivek Shankarji, I would request you for the last prayer before we close down, unless there are some questions you want to take on something. Okay.
And as Arjuna says to Krishna at the end of Bhagavad Gita, I don't have any questions. This is time for action. We all have to become Arjunas and kind of do our part. So let me conclude with the prayer. Sarve bhavantu sukhinah, sarve santu niramayaha, sarve bhadrani pashyantu, ma kaschit dukkha bhag bhaved. Om asato ma sadgamaya, tamaso ma jyotirgamaya, mrityorma amritam gamaya. Purnamadah purnamidam purnat purnamudachyate, purnasya purnamadaya purnameva vishyasite. Om shanti shanti shanti. Shri Gurubhyo namaha. Harihi Om. Thank you.
Thank you, sir. Very kind of